Assalamualaikum warahmatullahi wabarakatuh. First of all, I will introduce the member of the group. My name is Nur Alisha binti Mokhtar and my member is Nur Idina Najwa binti Qasrin, Nur Rabiatul Adawiyah binti Roshamidi, Wan Nur Syafawati binti Wan Ghazali, Wan Nur Arisa binti Wan Hafizi, and Nur Adlin Nadia binti Azhar. The topic of the presentation is about how to solve real-life problem using graph. I hope this presentation can be clearly understood. For this time presentation, I will explain about the problem statement. Now, I will describe an example of a problem statement in real life. A highway will be built that will connect 10 districts in the state of Johor. The cost in million to build each route potentially depend on distance and terrain as shown in the weighted graph below. Find the length of the highway to connect all the districts and minimize the cost using the classical approach.
I'm going to demonstrate how we construct our graph. So we construct our graph using the Graph Online website. So first, to construct the graph, we first need to add the vertex. So first click on the add vertex and click to the workspace to add the vertex. Next, we click on the connect vertices to connect the vertex and add the weight and click whether you are making a directed or undirected graph. For this graph, we are making an undirected graph. So we will continue to do the same thing until we will get the full graph that we are making, which is like this. So this is the final look of our graph.
In this part, I will tell you guys about the vertices that have in the graph that we use. To represent each vertices, we use an alphabet, and also each vertices is represent each district that located in Johor, which is A for Segamat, B for Ledang, C for Muar, D for Batu Pahat, E for Pontian, F for Johor Bahru, G for Kota Tinggi, H for Kulai Jaya, I for Kluang, and lastly J for Mersing.
Alright, so for now, I will demonstrate to you guys about the algorithm to solve this problem. So as one of my teammates mentioned it before, our team choose classical algorithm to solve this real-time problem. So basically, let's clear this up first. We have to choose the shortest path, or to more understand, we have to choose the least cost of the edge. We look at the table of the top of the graph first. So this one is the route that we choose, which is vertex A for Segamat, B for Ledang, C for Muar, D for Batu Pahat, E for Pontian, F for Johor Bahru, G for Kota Tinggi, H for Kulai Jaya, I for Kluang, and J for Mersing. So basically, we can choose any of the starting point that we want, but our group choose A as the starting point. So let's begin it now. We start at vertex A, which is at Segamat. We have to choose the shortest edge that connected to vertex A, either B, I, or J, and we can see it clearly that 1.5 is shortest one, which is edge A and B that weight 1.5. So we got our first edge. So we can ignore the others two because they are not the shortest one. So for B, vertex B, Ledang, 0.2 is the shortest one. They are connected to I. So we got our second edge, which is B and I that weight 0.2. And for I, Kluang, we can see that the shortest path of it, or the least cost of the edge, is 0.5, which is connected to C. Muar, and we got our third edge, which is I and C, that weight 0.5. And for C, the shortest edges that were connected to it is 0.6. We cannot choose 0.8 because this one is not the shortest one, so we choose 0.6. This one is the shortest one of it. And we got our fourth edges, which is C to D with that weight 0.6. And next, from D batu pahat, the shortest one that we can see either 0.5 or 8, 0.5 or 0.8. The shortest one is 0.5 that were connected to H. So we got our next edges that weight 0.5, which is D to H. So from vertex H Kulai Jaya, we can see it clearly that 0.3 is the shortest part of it, which is that we're connected to E. So we got our next edges. And from E, Pontian, we can see the shortest part of it is 1.8 that were connected to F. So we got our next edges, which is E to F that weight 1.8. Alright, for F, either 2.5 or 1.5, we can see it clearly. 1.5 is the shortest one. It is the least cost of the edge, which were connected to G kota tinggi. So we highlight this one. And we got our 8 edges, which is F to G that weight 1.5. And the last one that we can see, G, vertex G, which is kota tinggi, the one that have the shorter parts of it is 1.5, which is connected to G. And this is the last edge that we got, which is G to J that weight 1.5. So to make it clear, we state at this table, the first edge that we got is A to B that weight 0.5, and the second one B to I that weight 0.2, and the third one I to C that weight 0.5, and C to D the weight 0.6, and D to H that weight 0.5, and H to E that weight 0.3, and E to F that weight 1.8, I'm sorry, and F to G we got 1.5, and the last one we got G to J, which is 1.5. So we have to total this up, which is 0.5 plus 0.2 plus 0.5 plus 0.6 plus 0.5 plus 0.3 plus 1.8 plus 1.5 and plus 1 to 5 again. The total spinning tree that we got is 7.4. Alright, so this one. Alright, so this is the total of the spinning tree that we got. So that's all from me. I hope you guys can understand it this clearly. Thank you for hearing this demonstration.